Okay, friends, so if you are doing this experiment at home, which I highly encourage you to do, all you need to find is two objects, one white and one black. You want these objects to be as identical as possible to make this a fair test. So, for example, you would not want a white toy horse and a black purse because those are two completely different objects. But maybe you have two shirts or two pieces of paper, one white, one black, and they are as identical as possible to make this a fair test. So we are only changing one thing, the color. So for me, I have my white shirt. It's not perfectly white. It has this blue NASA symbol on it, but is the whitest shirt I have. So again, just work with what you have at home. As long as your things have some parts white and some parts black, that will work. This shirt is 100% cotton, and luckily, this shirt is also 100% cotton. Again, not completely black, but black enough. And these will be my two objects that I will be using for this experiment. But again, you find whichever objects happen to be working for you at home, and they do not need to be perfect. So now that I have my two objects with my independent variable, the color as my one thing that is different, which with as much as possible between the two objects, aside from that, you need to also select your dependent variable. The dependent variable means the thing that you are measuring that depends on the object that you are testing. So right now, to select a dependent variable, you should be asking yourselves, how will I measure heat, or how will I know which object acquires more heat energy after being left in the sun for an entire hour? So one thing we all, of course, have is our sense of touch. So you can, of course, be analyzing everything directly with your sense of touch and then base your results off of that. But our sense of touch can be a little bit biased. Sometimes we really want our hypothesis to be correct. So if the two are very similar, we might choose the one that is correct with our hypothesis so that we feel like we were right. So in order to avoid confirmation bias, what you can also do is you can find two ice cubes that are almost the exact same size. Then when you place both of your objects in the sun, place an ice cube on top of each of them, and if one ice cube melts significantly faster than the other ice cube, we will know that that surface is absorbing more heat energy, causing the ice cube to melt quicker. What I also happen to have that I would be shocked if any of you had is a thermometer like this. I have this to measure the temperature in an aquarium that I used to have that I do not have anymore, but this simply works by pointing it at something, and then you can see what temperature that thing is. So actually right now, I can see that this shirt is exactly 88 degrees. I can test my white shirt. That's over here now. And let's see if that's the same, because these I just got out of my dresser drawer. So right now, they have not been exposed to any heat energy at all yet. So let's see if that's the same. Ooh, 81. Let's test this again. 88. Oh, interesting. 83. 89. 84. 90. Are they getting hotter and hotter? Oh, you know what? Because I have this really bright light over there. Okay, so friends, what I'm actually going to do is I'm going to take both of these shirts, I'm going to put them back in a closet to cool down a little bit to make sure that we are setting up a fair test, and then I will be right back to help you make your data chart. Okay, so now that you have selected your two or more objects that you will be testing, at least one black and one white and one of extra colors, if you wish, you can set up this data table, or if you're choosing to do this on the Google Doc, you do not need to. But this is how I made my chart. In my science notebook, I wrote data, then I have 3 columns, 3 rows. I wrote my headings: object, observations after no sun exposure, and observations after 1 hour of sun exposure. Then I wrote the names of my objects, my white shirt and my black shirt. I drew a little picture, and if you are going to add more objects, you would just extend the chart down here and write any additional objects that you would like to include. So, without further ado, we're going to use all of the measuring tools that I chose as my dependent variables to measure the white shirt and the black shirt before any sun exposure. So I'm actually going to leave those in there probably for another half an hour to let them cool down, so I know this is a fair test. And then I will see you, well, a half hour for me, but 2 seconds for you. Okay, so to reemphasize, as scientists, it's our responsibility to be as fair and as honest as humanly possible during our experiments. That's why I chose 2 shirts that are as identical as possible. They're both 100% cotton, they're both the same thickness, and I put them both in the exact same drawer with no light energy so I can compare them first as my control before putting both of those same shirts in the sun for an entire hour to see what happens. So, before I use my other 2 measuring tools, I'm actually just going to use my sense of touch to feel both shirts, feel the temperature of both shirts, and see if I can feel any difference. And then I'm going to record my observations in my data chart. You can do that either on the Google Doc or in your notebook. So these actually feel similar to me. They're both room temperature. Makes sense. They've been in a room away from any sunlight. So in my notebook, I'm going to write that both shirts feel room temperature for both white shirt and black shirts. Now, I'm going to take my fancy measuring tool that I am fortunate enough to have and see what temperature they are. Let's try the black first. The black is 84.9 degrees. And now let's try the white. Oh, and the white is 84 degrees. So they're fairly similar. I'm going to write both of those measurements down, 84 and 9/10 of a degree for my black t-shirt and 84 and 0/10 of a degree for my white t-shirts. And of course, you can write those measurements down as well if you want to follow along with my experiment, or you can get your own measurements at home. So what I'm going to do now is I'm going to set up both of these shirts in a sunny spot and place identical ice cubes on top of them. If you do not have access to sunlight, that's okay because there's white light in your homes all of the time, and we know that the light from the sun is white. So honestly, as long as you take 2 objects and place them in the spot in your apartment that has the most white light, then you can do this experiment and see which ice cube melts faster. So let's go over to my window and I will show you how I am setting up my version of the experiment. Okay, friends, so I'm very lucky to have this nice sunny window. So I have some sunlight right here. I'm making a shadow right now on the black shirt. You can see that I was able to give both shirts a little patch of sunlight. So all I need to do now is pick out 2 ice cubes that are as identical as possible to make this a fair test. And we're going to see which one melts first. So let me see. This guy and this guy are the most identical in the bunch. Yeah, those are almost exactly the same. Okay, so then in a nice sunny spot, I'm going to place that on the black shirt, that on the white shirt, and then we're going to just wait 1 hour and see what happens before recording our results. I'll see you then. Okay, friends. So I just finished setting up the experiment myself, and I'm actually not going to show you my results right now. I'm going to show you the results in the next video because I do not want to give away anything if you're doing this experiment on your own. Remember, if you are doing this experiment on your own, all you need is 2 objects as similar as possible, 1 black, 1 white. You can add extra colors if you wish. I do highly recommend using fabric as well because the fabric will absorb the water that appears as the ice starts to melt. If you use paper, you'll just need to put something underneath it, maybe a towel, maybe a piece of cardboard, and you will probably need to replace the pieces of paper and get new ones as you perform the experiment. Also, quick note, while I was doing the experiment, I noticed that this cold pool of water formed on my shirts underneath the ice cubes, so it was okay for me to just at the exact same time move them to another dry area, 1 on the black, 1 on the white, both in the sun, so it would stay fair test, but also I'm not waiting around forever for ice to melt. So I hope you have fun with this experiment, and I will meet you in the next video when you are ready to write your conclusions. Bye!